So, hello everyone, can you hear me clearly? Great, great, great. So, good morning. Today we are going to discuss, first we are going to discuss with Hive and then the other topics, depending on how much time is available. Hey Prashant. So, last time we were talking about Hive, right? So, we said the discussion went on to, yeah, Prashant, health is good now. It was just a minor food poisoning that day, and I'm perfectly okay now. Okay. So the value proposition of Hive comes in because it provides you an SQL interface to most of your data. Instead of writing your map reduces all the time, you can write the same logic in your SQL. Okay. And the value proposition of SQL over Pig is that lots of people already know SQL and it is very easier for them than learning a new language like Pig Latin. Okay, and the other ones we had already discussed. So now we are going to jump in into how to start using Hive and what is the construct below Hive, right? We also discussed a higher level diagram of the architecture of the Hive. Where does it, where does it lie in the ecosystem of Hadoop? So, as a quick overview to what a Hive query looks like is this one. So, how many of you are comfortable with SQL? Or let me ask this way: who is not comfortable with SQL? Okay, okay. So, Zimi, you are not comfortable with SQL. Okay, okay. That means you're so everybody's. I'm assuming Prashant, are you familiar with SQL syntax? Huh. So basically, I'm assuming that all of us are familiar with SQL, and if not, no, proficiency is not required. Okay. So in this quick example, the word count example which we tried to solve using maps and reduces, right? We had created keys and value where key was a word and value was one, and then tried to reduce by summing up the values. Those that required a lot of programming. Okay, we had to write the code, then ask Hadoop to execute it. In case of Java, we have to compile it and those kind of things. But most of these tasks can be quickly done using either Pig Latin or using Hive. Okay, or a combination of Pig Latin, Hive, and then your MapReduce. Okay, so here the way we are going to solve is the word count is, we basically created a table which has got only one column called string, column of type string, and the name of the column is line, and the name of the table is docs. And we have loaded this file, so we have loaded this table from a file called this one. Okay, so we loaded docs table from a file docs. So now we can assume that we have got a table containing the data from this file, and is having only single column called line. Okay. Now we created another table called word count. Okay. And we created this table after selecting word from this one. Okay. So what we did was we first split it from with a new line here, space. Basically we split it based on space. After we split based on space, we explode it similar to what we did for pig. And once we do that, we what we do is that we group by word and order by word. All right. So after we splitted the line with a space, we broke the line into various words, and exploding means we converted it into multiple rows. After that, we grouped by the word, and that's what we got the count. And once we did the count, we inserted into the count. So when we say select star from word count, we would get, okay, we will get the same thing. Okay, now good. Hmm. No, actually, we have given it a name here. Okay, we have given it a name over here. It is actually supposed to be a word. Suppose, just a second. So what's happening is, actually, it has to be like this. Okay. No, actually, right. Huh. Basically, here, this is basically an alias to the whole table. Okay. And if you look at it from that perspective and delete it for a time being, you can see select w count 1 from as count from this particular table. Okay, so this is the name we have given it to the we have given it to the table. Okay, right. So ideally it should be w dot word order by w. Perfect, Arun, thank you. So but that works out exactly like SQL. You don't have to specify the full. If there are no confusion in the name, generally SQL is quite forgiving, right? So this is just, even if you did not understand it, all I wanted to show you that most of the work, which similar to what we did for pig, we wrote in the beginning we wrote a small script which did the same thing like explode and then group by, right? Now the downside of this thing is it's confusing. Confusing in the sense that first we created this set, we tried to, so there's a nesting involved here, and that is what confuses us. And big guys, big guys made sure that we don't get confused. Okay, things should be in the order. First, you should explode, then you should select from it. So those kind of things. Now, how to start using it? Log on to either of Hadoop 1, 2, or maybe 3. I have to see where all the Hive client is installed. Okay. So Hive is basically a client, which means it doesn't have a server other than maybe a Hive web etched where it stores the data. Okay. So Hive is mostly a client. Right, right. You're right. So yes, you can have Hive client installed in your local machine, and you can set the config to use it the no big data's cluster. But for doing that, make sure that you have put your SSH details in place. Okay, you should make your SSH access to Hadoop cluster is such that it doesn't require a password. You can set up a password free access, okay, by copying your private key. So Hive clients, 4 clients are installed. Okay, and they are installed on 1, 2, 3, and 4. Okay, right. So on all four desktop, on all four machines, we have a Hive client. So you can use hadoop1.nobigdata.com, hadoop2.nobigdata.com, and till 4. Any of the machines you can log in and start using it. But my preference will be Hadoop 1 and Hadoop 2 because they have got a bigger memory. But anyway, whatever works for you. And you should once you log in, what you should be doing is that, oh no, this one, I'm sorry. Let me increase the font. Right. So once you log in, you type in Hive, and you should quickly get a, not that quickly. Yeah. So here you can start working on your tables. Okay. So as a first exercise, you should try to execute this command after loading file, the older file which we did. Okay, and then you can do. So Hive, you can execute your query by typing on the console over here. Select star from somewhere to somewhere. Okay, or you can execute a command like this if you want to just plan to execute a single query by saying hive minus e and your query. All right. And the third one is that you can load your all the SQLs from a file and get it executed into Hive. Right. So these are the three formats in which you can execute your queries. Right? And general trend is that we create a table like this. Okay. So we said create table X, and then we did the, okay. This is just a very quick demo. Okay. So I selected from it, I deleted it. Okay. The awkward part is that you cannot insert rows into this table because Hive is meant to be the analytics tool. Okay. Therefore, it does not allow you. It doesn't allow you to do the record level insert, update, or delete. So this is what we call Hive prompt. A little bit about this. You can run Hadoop fs command directly. Okay, like we say, not this one. We say dfs dfs minus ls. Okay, so it is basically connected to our Hadoop cluster HDFS and giving us the output. Okay, and if you want to just quickly see, I mean, say, so dfs cd No, not this way. All right. So basically, Hive provides you similar to Pig, not that comfortable as Pig. It provides you the a way to quickly use the DFS commands, and either you can load a SQL. I mean, load a HQ. It provides the query language which Hive uses. We call it HQL instead of saying SQL because there are minor differences. You can load a Hive script onto a command prompt. Okay, and most of the commands in your file are basically starts with dash dash, similar to any SQL. And then there is a good part that you can create these variables. All right, similar to other. Okay, so you can see, and you can see, hmm, so it doesn't seem to work for me, strangely. Okay, okay. So basically, it allows you to access the environment variable if you define an environment variable, and this way we'll look into this again. Basically, you define the variable in shell over here. Okay, you define the variable in shell like year. Okay, and then you went into Hive. Anyway, we'll see it later. Also, you can execute most of the local commands by using exclamation, similar to what FTP clients and other clients provides you, because FTP clients and other clients also allows you to execute local commands using exclamations. Right? So like, so here you might have to put semicolon once you finish your command, and that's all. Right now, in case of Hive, there are these various data types as similar to most of it. So since under the hood, the Hive will be converting your data types into Java data types, and therefore most of the data type will be similar to what Java provides. Okay, and it is basically bridging a gap between SQL and Java. So it will be most likely it is providing you the data types of which were there traditionally in SQL, as well as the ones which Java provides. Okay, So you have got tiny, which is tiny int, which is single byte, a small int 2 byte, integer 4 byte, big int 8 bytes, and so on. And string type, earlier it was only providing you the string. Now it has started providing you varchar to be compatible with other databases. And timestamp and date also came recently. Char, varchar both came recently. All right. So the other than your basic data types, which is your integer, float, and double, and decimal, and string, and character, and date. Other than that, it provides you the complex data types. Complex data type can be an array, can be a maps, can be struct, can be union. Okay. Union came very, very recently. And this is an example how you define it. So name equals to string. These two are not complex data types, while subordinates is an array of a string. Okay. So this is a little bit different from our traditional SQL. And we can also define map as a string comma float, which is a key value pair. And then struct is something which is a structure like your C. Okay. And then union is exactly like union in C. Struct is basically like a class or object in any of the programming language, which is basically predefined keys, and then you have values. Okay. It is slightly different from map. Map has got dynamic keys and then values. In struct you have predefined keys and predefined values. And also this number of these values are fixed. You cannot dynamically add more things to address. Only these things are allowed. All right. So this is how these are the basic data types. And union type, I have not taken an example over here for union, but union type is basically same memory for all the data, being all the values stored in a struct. So union type is similar, looks similar to struct, just that either of the only one of the values, one of the keys will be having the value. It will be stored in the same memory location. So here you can say show databases. So it shows you all the databases which are there. Okay. And you can create your own database over here. Okay. I'll be creating I'll be creating say Asgiri over here. And if you get this prompt without hive written on it, just put a semicolon, and that should do the trick. Okay. And here after that you can see show databases, and I've got asgd created. And let's say that I use finance human resources. Okay. And under the human resources you can see show collections. Not show collection is in MongoDB. Semicolon will work in case of pigletin when sometime. Yes, yes, yes. No, but what happens in case of pig? You should take a look at your query. Maybe there's an open quote, double quote or quote, which is not yet closed. All right. That could be another reason to when the prompt goes away. And in that case, you can simply press Control C. But that will kill your command prompt, and then you have to come back again. Start pig again. But looking at your statement in pig, you can figure, if you can figure out that there is either a single quote missing or double quote is still continuing, then that will help you. So yeah, so we have got, and similar to SQL, we can say describe table this and show collection. I'm trying to see if I have a collection. Sorry, not show collections, show databases. Okay, and we have got Alex default. Okay, and let's say use show tables under the default one. We have got so many tables. Describe employees. So it shows you that employee has got a name, salary, subordinates, deductions, and address. Basically, this table which was there has been created already. So you can say not that way, because so this way. hmm So this double quote is troubling us. Okay, so here we are good. Somewhere down the line, if it is there's a tab, then it bothers us a lot. Okay, and we say, oh man, okay. Basically, here there are these spaces which my PPT has inserted by itself, and it is actually bothering. Never mind, I think the script would be there. 4977. Yeah, it is that. It is that strange space which is causing a problem over here. Okay, okay. So we have created a table called employees. We can say describe employees. I'm sorry. So we can see that employee has got name, salary, and everything is created correctly, right? And also, if you want to see the current database in your command prompt, you can set this. Not this way. Yeah. Yeah. So it shows you that which database you are in. It shows you that command. So if I say use sgiri and then the command, the prompt will change. So those are nice little things about this. And also we can drop our database. And similar to your Oracle, we have if exist kind of clause available, right? So All right. Now, now under the describe, you have two kind of describe. One is extended, other is formatted, and use default, use default, and I say right. And but this is not great. So instead of that, a better idea is to have formatted. So formatted basically displays everything about a particular table. Okay, so here you have got column name, data type, and comments, and then partition information on which columns the table has been partitioned, and then the table detail in a fashion where exactly is this table stored. So as you can see from here, this table has been stored at this particular location in Hive. Okay, you can go into this table and see whether this exists or not. All right, so you can do that, and so you can see that we have got dfs minus ls. You can see that there is an employee table existing over here. All right, employee direct, it is an employee directory which does not have anything right now. Okay, it is an empty directory as of now, and so basically the this one will give you a lot of details about a table. If it is existing at multiple places, that also you can get the details here. Okay. Basically, if this table is having a partition and is being used from other tables. So so there are basically two kinds of tables in Hive. Okay, this information it's getting from name node. Yes, so this information basically is stored in the metadata of your Hive, and Hive is storing this metadata in HDFS. Okay, and so this client is retrieving the information from HDFS, and then when it tries to retrieve any information from HDFS, the same routine of asking name node and then getting it from data node applies over here. Okay, okay. Now there are basically two kinds of tables. One is managed tables and external tables. Okay, what does it mean by the two? As we had already described the role of Hive, the role of Hive, other than you being able to analyze, the data in HDFS, it allows you to connect to various kinds of NoSQL databases as well as SQL databases, is structured as well as unstructured. Therefore, Hive came up with the concept of external tables, okay, and managed tables. So managed tables is something the way we just created a table, create table XYZ, and we will load the data from locally. Okay, so whenever the data gets stored in any of these tables, it gets stored in HDFS, or any other data sources. So the good part about the managed tables is that their complete life cycle is managed by Hive. If you drop the table, the data also gets dropped. While in case of external table, they act like a channel. They act like a channel to an external file. So if you want to read anything from that file, it will be reading through that channel and getting the data. And in case you drop an external table, in case you drop an external table, Prashant, the class is being recorded. Okay. So in case you drop an external table, the data will remain intact, only the reference will go away. So the metadata of this table is being managed by metadata, as in what kind of column it has, what are the various column types, and what are the various uh, information like partition information. Those kind of metadata is being managed by Hive, but the data is existing somewhere else. All right. Managed tables are internal tables, which are basically, if those tables vanish, the data will also vanish. So that is the difference between the external table and managed tables. So when you define these tables, you also define that this is my data. In case of managed, you also define that this is where the data going. Right. So you are right, Arun. So we can load data using Hive only when creating a table. There is no such thing as insert into this, insert into that. You can do an insert. You can do an insert by using another select star into this table. All right. Yeah. So your question is, we can load data using Hive only when creating a table. Yeah, so it is mostly that way, but load will work even if table is already created. Right, right. So basically, in case of SQL, you don't have a syntax like load the way we had in pig, right? So you define that this table is external or internal, and you define that this is the file or this is my, say, database name. And once you do that, you can either select from this table, or you can insert into this table only set wise, as in select star from that table into this table. That's all right. Okay. So was I able to answer, Arun? No. Okay. Now, so basically, this is one interesting idea that it has got managed tables and external tables. Now, let's say you want to read a CSV file. All right. If you have an external file, so I'm trying. Basically, this is an answer to what uh, Ajay was asking. I think. Yeah, Ajay was asking. So how will data be sourced into external okay, data will be put into external table using other mechanism. Whatever you have an existing mechanism, say you are bringing the data from your traditional data warehouse or some other mechanism. Okay, so data will be put into external table by them. It's not you don't own such tables. External tables are not your ownership. You are basically entitled to read this data to derive various kinds of analytics. Yes, we can create a new table area like the way we did here. If you can see that we created a table here. Okay, create table employees. It will be your own table. It will be internal table. All right. Now here we are creating another another kind of table called external tables, and all we are trying to do is we are trying to read the data from here into into this table. All right, let's see if we can try to do it. It will be good if we are able to execute this. Okay, now we say dfs minus ls and dfs minus ls, and we say data, and out of this we say, I think this was in New York daily, right? NYSE daily. All right, now we can load this table into, it doesn't allow me to do that. Hadoop minus fs. Okay, never mind. Now we have got this table and we have got this. Now what we can do is can load data from there, and I doubt if we have dfs minus ls data. Is it there? No, we don't have that one. So what we have to do is we have to take this. Okay, okay. So this presentation is actually bothering me a lot. It is changing all my formats. All right, never mind. So basically here I was trying to demonstrate to you that if you create an external table, if it is does not exist called stock with all of these values, and I'm saying row format delimited by comma, all right, and the location is data slash stocks. It will load this comma separated file, into the system. All right, basically it will create an external table which is located at this location and access gives you the access. Okay, and whenever you try to do a select star from stocks, you will get, it will query this csv file, it will load the csv file every time you do select star from stocks and give you the data. Okay, it is just that I'm not able to execute it because of the formatting issues. Never mind. I have a demo. I will give a demo at the end of it. Can we configure primary key etc in a Hive table? Right. So because this table, say this is not on HDFS, this is on some say file system, physical file system. Right. We are trying to load the data from there, and we do not want to manage the life cycle of it. If we drop the stocks, this table will not be dropped. Okay. This table will not be dropped. And also it is in comma separated format, so we only have an option of loading it externally rather than creating an internal table. Right? So therefore it makes a lot of sense to just load it externally. It is like creating a view over a physical file somewhere, where when you say select star from stocks, it is going to query that CSV file and bring the data to you instead of you reading that file. And then you can join this kind of data which is in CSV format with your H based data or with your other kind of data. So you have created these kind of tables which are basically like a symbol or metadata, and they actually point to various kinds of resources across the network. It can be an H-based table, it can be a MongoDB collection, or it can be a local file, and you can then join all of them together to derive the insights you are looking for. Okay, you can do analytics on top of that. All right. They therefore, so external table don't contain data. So whenever I did not get your question. So do you mean to say that external table do not create the data or do not contain the data? So external table, this one, when it gets created by Hive, just the metadata of it will be created by Hive and it will be put in the Hive's metadata store. Okay, so whenever we are saying show me all the tables, it will show that there is some table called stocks. And if you see into the details, it will also tell you that it's an external table, which means any date, anytime you query it, it is going to query an external system and give you the data. And if you drop this table, that external data will not get deleted. Okay, it just get linked. All right. It is like having a symbolic link to a file, and the internal table is like having the direct link to the file. Yes, yes. Thank you, Arun. This is similar to Oracle. Somebody also told me the same thing. I'm not very great with Oracle. I have been mostly using SQL and MySQL. Okay. So yeah. So it looks like Oracle also has got external table, and most of the nomenclature which I'm seeing with Hive is actually similar to Oracle. Other is the partition things. It has provided the partition syntax similar to Oracle. Okay. Now, there is a concept in case of a Hive called partitioned. Okay, and it basically provides you a horizontal partitioning using HDFS. And what does a horizontal partitioning mean? Horizontal partitioning means that some of the rows will exist on one file or in one location, and some of the rows will exist in another location. All right. So here you can see that if you, let's say we create a table called employees and we say partition it by country and state. Okay. And so all it will do is it will create a table called employees. All right. And sorry, it will create an HDFS directory called employees, under which there will be subfolders like country equals to CA, and then another folder will be there, state equals AB. All right. So that is the way partitioning happens. So it is going to, by default, if you create a table called employees and then load the data into it, then it is going to create these kind of folders into the physical file. All right. So every time you're going to insert the data under the employees directory, you will going to see these subfolders. Say you had created only one partition criteria, like partition by country, then you will see these kind of folders only, like under the employee you will see country equals CA, country equals India, and so on. Right. So that is the idea of partitioning in HDFS. Okay, so describe employees, and right. So Deepak's question is, what is the benefit of partitioning and use case? The benefit of partitioning is multi-phase. If you have some rows coming into a table, in case of external tables, coming from various locations, or you want to basically store these as separate files. Okay, meaning that some of the data, this is like a manual partition of any data. Okay, this is like manual partition of any data. And in case there are very big files, in case there are very big files, in those cases you would like to basically split it into various sections and store it in different files. Okay, so yeah, so every time you say select star from employees where country equals CA, it will quickly locate this file instead of going through all the records. It will quickly locate the first one and give you the results. But there will be indexes also onto these tables. Okay, so that retrieval is anyway assisted by indexes. Okay. Here, the sole objective of partitioning is going to be division of data into multiple disk or multiple places, so that so that basically load balancing and distribution of data can happen. All right. Now, external table can also be partitioned. The way it is described is like, you create an external table. If it doesn't exist, you can create that external table, and then you define that it is partitioned by year, month, and day, and row format delimited by such and such. All right. And later point of time, you can add, you can keep on adding the partition, saying alter table log messages, add my partition for year equals 2012, and my location is HDFS. Uh, Okay. So basically, yes, yes. So what I'm trying to demonstrate, I'm trying to answer your question here. And basically, if you, the real usage of an extra of a partition table is visible only if you are using external kind of tables, because internal tables are anyway stored on HDFS, right? A- and therefore they are anyway load balanced and the data is well distributed because of HDFS, right? So in case of external partition, you can see that here in this particular case, some of the rows are coming from HDFS, some of the rows are coming from S3. S3 is Amazon's 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 way of providing you the data. Okay, so you can upload the files, upload the data into S3 and load the data directly from there. Okay, so say for example, what you are trying to do is, you have say Amazon provides you a lot of public access to the free data. Okay, free access to the public data. So you basically all the sort of data such as population of the world and even corpus of the internet, they provide you for free. Now, instead of copying the data onto your disk, you can simply use that in your external table, right? And this is that one. So S3N is basically their location. So you can see that for year 2011 and month 12 and day 2, all the data will come from S3, while all the data for this criteria will come from here. But when you say select star from log messages, the data from both the places will get printed. But if you say select star from log messages where year equals to 2011, then only the data will come from S3. So basically, this is the magic which Hive provides you, where some of the rows can come from one place, some of the rows can come from another place, and the user can very seamlessly join this table with other tables and get the results. Okay, Hive will do the heavy lifting of bringing data from all these places and joining the data together. Okay. Yeah. So yes, it means that if every time you are going to query log underscore messages, it is going to hit both or either of these partitions. Okay, and you can create as many partition as you wish. In case of internal tables, it was creating these subfolders by itself. In case of external ones, you can define your own. Okay, also remember that when we are partitioning a external table, we don't have to define, we can, because when you are defining any external table, you always define it with the location over here. Okay, whenever you're defining an external table, you have to define where is it located. But in case of partition table, you don't have to define a location. You keep on adding partitions as you go. All right, it doesn't copy any data from external to the local. In the local metadata store, it only has the metadata like data type, indexes, and all those sort of things. So these are standard syntax with respect to SQL. Alter table log message, rename it to something else. Changing the column, you can say alter table my log message and change various columns data types. Okay. I mean, this one is basically renaming the column, and we can put a command exactly the way our standard SQL works, and we can drop a particular partition also. Alter table log message drop if exists this particular partition. That's it, and this will drop the partition. So every partition is identified with these values. This is sort of a composite key which defines a partition. All right, this is sort of a composite key which defines a partition, and which means that this has to be unique for all the cases, so that there is no data conflict at all. In case somebody else is trying to declare that this partition 2012 partition with same months and same day, it will give error. All right. So okay. So yeah, yeah, yes. So as I was saying, when we source different partition from different sources, then there might be change in the format. So if there is a change in the format from various location, then it is a bit of problem. Okay, here here we are saying that the row formatting is basically we have done it on the log messages on the table per se. I'm not very sure if we can define row format per partition. I'm not very sure if we can define the row format per partition. Okay, say you have a tab separated file in S3, and while you have a comma separated file in local file system or network file system. So can we have a can we still have an external table pointing to the same one, right? That's your question. So I'm not sure about this because I mean I've mostly seen that when you define a table, at that moment of time you also define the row format. I'm not sure if you can define row format while adding a partition. Okay, I'll have to look it. I'll just take a note. Okay, okay. So, Arun, in case of Oracle, do we have this facility of loading the comma separated files into the table the way it is happening here, or the table has to have the by a standard format of Oracle? Okay, and the external table can have what kind of format? Okay, great, great, great. So those who are from Oracle background, it will be quick for them to actually, uh, you know, work on Hive. So in Ajay, in case of external tables, the data does not get loaded. Okay, but in case of internal tables, the data gets loaded over here into the table. Okay, data gets actually copied into the local table. Okay, when you say load, the way we were discussing earlier, when we say load, the data gets copied into the local one, while in external one, nothing happens. Okay, so here we can, you know, if you have a managed tables, you can load the data using load data local in path. Okay, in overwrite into table employees, right? And also we can mention over here that this should be loaded into this particular partition. All right. In case you have a partition table, then that particular partition which is having this sort of a composite key, only this data will be loaded into that. Or you can also think of it this way, it will get loaded and then partition based on this one. Okay, but for timing you can just focus on this part. I'm saying here we say load data from this particular file, physical file, and the format, whether it has to be comma separated and or has to be tab separated, will be defined while we are defining the employees table, and then we load into it. Okay, so this loads the data separated by control A by default. If you do not have defined a comma separated, okay, in case the data is already existing in employees table, the the data will get overwritten, meaning the table will basically get, all the rows will get dropped. Okay. So okay. So load data local in path from in path as in local in path as in from local files instead of loading it from HDFS. If you don't say local, it will start reading from the HDFS. And then after it gets, I mean, it will basically load the records from here. By default, it expects the columns to be separated by control A. Okay, and now control A is a little bit problematic. Therefore, I mean, by default, that is the format which Hive handles. Okay, so but you can always, while creating your table, you can always define what is the separator, comma, tab, or if you don't define any separator, then by default is control A. And this will basically create a directory for this particular partition, whatever you create over here, and then copy the data to that directory. Okay. And if that target table is not partition, then you don't need to give this partition at all. Okay. So this is generally for the cases, this third line is generally for the cases if your table is partitioned. And so this is the same thing, insert overwrite local directory, select star from this. So here this is loading into the file and this is saving into the file. Okay. So there was one file called California employees, and we loaded that into the table with the country state California. And then after you have loaded, you are saving it back into another file called /tmp/ca employees. Yes, Savita, the describe will tell you in detail. If you have a, basically you do a describe formatted and then table name, and it will give you all the partitions and all the details on where is each partition located on the disk. All right. So this way you can save the data back into the file system. Here, this way you load the file, load data from one file to the table. Here it's like import export. Okay. Now most of it is very similar to SQL, so I'm going a little faster. Right? So select name comma salary from employees. Select e.salary from employees. Basically, you can either give the alias to the table, or you can directly access the column names. Okay. And this way you do the computation on the columns. Select upper name salary, and then you have deductions, and then here you can see that deductions is a map. Okay, deductions is a map you saw in the previous examples when we were talking about here. Deduction is a map. Okay. And in the deductions you can see that we are loading it from the we are saying that with this particular key we require. Similarly, we can have the computed columns like SQL. We saying round salary into this and that, and then we are selecting it from the table. Right. So this is what it is. Basically, you can have either the, this is also a computed column. This is a computed column, and we can give the name with saying as XYZ. Okay. So this is very, I mean, there's nothing much difference from the standard SQL. And most of the standard aggregation functions are available in Hive, like select, count, star, average, and okay. and some of the so basically whenever you are doing a computation like group by or any other sort of computation, and in case it requires to do a data churning, then it will use the map reduce from Hadoop. Okay, say you say in case of our first example where we were splitting a line by space and doing all of it, so it will under the hood create maps and reduces to execute your SQL query. Okay, it will convert the logic in your SQL query into maps and reduces and execute on top of Hadoop. Okay, and whatever results you get, it will again convert it in tabular format and give it back to you. All right. So anything you do on top of Hive, it is going to be under the hood. It is going to convert it into maps and reduces if it requires to do so. Okay. Even if your table is external, if you do a lot of processing on top of this like group by or anything, it is going to execute maps and reduces for the computation of the values in that SQL. Okay, so say for example group by will emit a map and reduce. Map will be having a key value pairs, while group by will while your reduce function will aggregate the values and apply whatever aggregation you have done in in your function. Say average is going to be in your reduce, while count star can or may not be in the reduce. Okay, so to optimize the performance of Hive, you can mention that hive.map.aggregation equals to true. So the top level aggregation such as count or such as average can be done in the map phase itself, because computing average of values is does not require you to sort the data. Okay, say you have lot of values for something. Okay, let's take a case of say average. Okay, average of a particular value requires summing up all the values and dividing by count, right? Now in case this does not require the data to be sorted, all you can do is you scan the data from top to bottom and keep on summing up all the records, and then say and also count the total number of records and divide the sum by the count, right? So it is like your map phase where you don't require any grouping or anything. You read the data line by line and keep on counting this. So if you tell Hive that in that that do the little bit of optimization, so such kind of functions like average and count will be done in the map phase itself. Okay, now how should so I'm very sure you did not get this part, did you? So what I'm trying to describe over here is, say you have got word 1 and then my salary is 10. Let's say employee 1, employee 2, the payment was 20. So we have got, let's say imagine that we have got employee table where its name and it is the let's say payment. Okay, and compute we are trying to compute okay, we are trying to compute what was the total payment done to, okay, total payment for each employee. Okay, each employee. So it's pretty simple. Can somebody tell me a quickly an SQL query which does this? So we have got a table, let's call it employees, in which we are recording the name of the employee and payment done for the employee. And what we are trying to do is we are trying to compute the payment done for each employee. So what kind of SQL query will you be writing for this? Right. So anybody else? Great, great. Thank you, Ajay. Thank you, Arun. So basically select name, and I'll just copy somebody's, yeah. So yeah, like this, right? Now if you think about what it did under the hood, if you had to do the same thing in case of a map reduce, the map will basically simply do nothing. Map will basically do nothing but make the employee name as key. Okay, key is employee name, and the value is your payment. Okay, this is what map of map reduce. Okay, map part, map phase, you can say map phase will do this part. If you have to write the same thing what we have written here as SQL query, we'll write key as name and value as payment. Okay, in the reduce phase, all we are going to do is return sum of values. Okay, so basically you can see that, and almost every query can be broken down very easily into maps and reduces, right? So in case of a group by, whatever is the key in the group by, you make the same key in the map phase. All right, and whatever values you are expecting in the select statement, you make sure that those are available in the value part of the map phase here. And in case of reduce phase, you basically use the aggregation function, whatever is being used here. Okay, so similarly, so reduce phase and map phase are very analogous to a group by. And in case you don't have a group by, okay, in case you don't have a group by, then you do not require a reduce phase generally. Okay, say we say sum of this one, right? In this case, irrespective of the employee, the total value will be summed up, 30 plus 20 plus 20 plus 10, in case there is no group by over here. So in those cases, ideally, most of the Hive should have been doing an optimization automatically, but it might go wrong at few places, or it might be doing an over optimization job at few places. In such cases, the you would like to do the sum itself with the in the mapped phase. Okay, in the map phase itself here, without a reduce. Okay, so so for these kind of cases, you can mark hive.map.aggregation equals to true. And Arun's question is genuine, that why isn't this setting default? Ideally this should be default, but probably to avoid lot of over optimization, they have marked it as false by default. Okay, but ideally it should be able to figure out from the query that here we can do an optimization. Pig has done it very well, but Hive has not. Maybe Hive does not has not been able to figure that out. Okay, okay. Because this portion, like set hive.map aggregation, might result erratic. Okay, might result in erratic values, in case there is a group by, but I believe that this can be done very well, and this can be figured out. Okay. So the idea here was to explain that uh, any SQL query of Hive under the hood gets converted into maps and reduces, and you have some control over map and reduce, the way map and reduce is being done. So here what I plan to do is I give you a quick demo before we go for any break. So let's say drop table u underscore data. Okay. Now it has created u underscore data. So nothing is existing. So I'm trying to create a data table which has user ID, movie ID, ratings, and Unix times. Okay. And the row format is delimited. These are delimited fields terminated by slash tab and stored as text files. Okay. Now, for you download this movie lens data. I have already downloaded movie lens data onto my local folder. So, so let me just say Control Z. Control Z sends any process into the background. That's far more comfortable. And once you are done with your other stuff, then you can. So I have already downloaded. You can download using putting an exclamation and running this. It will basically download this file into your local folder. Okay, and then you can unzip it and then see if it is existing there. And so what I'll do is I'll actually do the whole loop again. That will be easier. So okay, so it is downloading that file. It has downloaded it, and now it is extracting it. Oh, okay. So rm. So here it's anyway done. Okay. You can actually do it in your own folder. And once you are done with it, you can say that load this particular file. If you see, I have already downloaded not okay 100,000 not. So it's basically a big file which contain 100,000 records of people who have done who have done some ratings of movies, and it's called u.data. So this contains a tab separated values of user ID, movie ID, and the rating, and on what date in millisecond it was watched. All right, and then you can go back to Hive and say load. Oh man, the problem is with the my PPT. It changes these comma codes into strange codes, and And the awkward part is that starting with IBM, Microsoft, and Apple, they have a different ASCII value for their different kind of codes. So it says that, did I again messed up somewhere? Okay, so Hive, let me just copy this data into a text file. Yeah, this looks okay. Now load this and semicolon. Mismatched token exception. Mismatched end of the input you have expected near in the load statement. Oh, I'm sorry. Actually, one more line has to go there. Load data. Yeah, that's right, right? Load data local in path into overwrite u underscore data. U underscore data. Just a second. Overwrite into table. Okay. Overwrite into table. Yeah. So basically that thing is missing over here. I'll just fix it. So here we have to put some more things. Okay. So it will be like this. All right. So now it has done it. So it has loaded the data whatever we had properly into u underscore data, and then we can do select star from u underscore data. Okay. And similarly, what we can see is if we have to quickly see select distinct. Okay. And we have defined our table like this, and we want to say select distinct user underscore data, user id. Okay. From u underscore data, we can say not this. Okay. Oh, okay. So basically it is computing the distinct of the user id, and to compute distinct it will be creating a map on user id, and then in the reduce phase it will remove the duplicates. All right. So it's basically doing a mapper reducer for you, and exactly like any other map reduce job, it has given you a URL 8088 tracking URL on which you can track, and it is showing that the map job is finished now. Okay. And here it says that you can also do various optimizations. So these are the various IDs which are done. Okay. And similarly, we can keep on, if we want to do that, we want to see that how many on an average on how many movies each user rated. So what we can do is we can say, so we can say movie id count movie id from this, and group by user id, right? So basically, this is a data where we have 100,000 actual values of which person liked which movie. So this data called movie lens is heavily used in case of any recommendation, building the recommendation engine or any other kind of things. It has a detailed listing of all the movies and which user liked which movies how much. That kind of details are there in the this file called ml u.data, this particular file. And under this folder you will also find all movies, and each and the user, when the user got created, for how many days, all those details are also there. So this is the real data. And on top of it, you can do all sorts of churning once you have loaded it into Hive. Similarly, you can also do the same kind of churning on top of using a pig. Okay, in both the cases, whether pig or Hive, the actual job is done by MapReduce. Okay, the way uh, you had done it in the first and second and third sessions. All right. So yeah, this is stored as a text file. So the data is actually in the text file, and we have loaded it into our table, right? So here you can see, and as an assignment to this class, all of you should try to do the same exercise, where you download this movie into your folder, create a folder and create your own table. Instead of you underscore data, you create your own table, or you create a separate database and load everything into there, and then try to do all sorts of a little bit of analytics on top of it. So this data is nothing but user ID, movie ID, rating ID. So for each movie ID, what is the average rating provided by the user? All right. For each movie ID, what is the rating provided by the each user? And there are a lot of interesting things which are done on top of such kind of data. All right. And then on this one, what you can do is you can do an how the way we are doing right now, for each user, how many movies they have rated, right? Or you can also say that things like you know here, what various kinds of things you can do is, for each movie, how many users voted it. For each movie, what is the average ratings? Okay. And then you can also um, okay. And yeah, so I mean, these two things you can do as an assignment on the top of this data. You should be creating your own table, and then you should do these two things. Okay. So that's pretty much about Hive. Okay. This is a very, very quick session on Hive, because most of it is anyway covered in SQL. All right. So these two things you should be doing it as a homework. And I want to take a little break and then come back after 10 minutes. Right. So we'll take up the next sessions. Basically the session on. I'll show you that, because there are multiple topics to be taken. Like we have a zookeeper in the next sessions. Okay. Because there are a lot of technology stacks. All right. And okay. So in the next session, after the break, we'll be talking about HBase. Okay. So let's take a break. Hi everyone, I'm back. Should I start now? Okay. So Tuhini is here, Savita is here, Jim is here, and yeah, Arun, Ajay, Prashant, Gunjan, Deepak. Okay. So today I will be further discussing HBase. Okay. And then HBase is little more, little the basically right. Okay. I'm going to discuss two parts in HBase. First part is about general what is NoSQL databases, and other part is specifically with respect to HBase. Okay. All right. So I think I should start, except for Ajay. Everybody is back probably. Okay. Ajay is back. Deepak. Okay. Deepak, Iraya. Okay. Never mind. Okay, so now we are actually running around 1.5 hours delay with respect to the standard class. So never mind, I'll just go at my own pace. No need to hurry. Even if required, we will have one more extra class, 11th class, to but will not skip or will not hurry in any way. Okay, we'll just go at the natural pace. Okay, so does it make sense? I mean, hope nobody has a problem with having an extra class in case of instead of hurrying up. Okay, does it make sense? All right. So basically, today we're going to talk about HBase and NoSQL. So first, we need to understand why do we need such new systems in place. Okay, okay. So next Sunday you are not available, Savita, but next Saturday you are available, right? Huh, then it's good enough. Yeah. Okay. So okay. So now let's talk about something called NoSQL. Okay. We have talked about few things till now. First one, we talked about HDFS. Then we talked about a paradigm where how do we build our logic such that we solve our problem and still our logic get distributed across multiple node over HDFS and using MapReduce. That was MapReduce we talked about, and we went into a lot of we took couple of examples, and then we went into Pig. In Pig, we basically the idea of HDFS was to store data in file system, having a lot of data in petabytes, and on multiple nodes with having a great efficiency and performance and ability to quickly read any chunk of any file. So that was the quality of HDFS. Then we talked about MapReduce. MapReduce is basically helping us execute our logic
on top of a Hadoop cluster. Then third one was Pig. Now we need, instead of keep writing our logic in code, we needed a query language. For that, Pig and Hive were the uh, two tools provided by the Apache stack. And these two tools are quite analogous to each other. Just that Pig is very heavily tuned for distributed processing. Okay, big data processing or distributed processing, while Hive is for the people who are coming from SQL background, but they do, both of them do a decent job on top of the same. And Hive also provides you one more addition, that it provides a lot of drivers, because all it needed to do was little bit of tweaking into the standard drivers, and was able to provide a lot more drivers as compared to Pig. Also, Pig also aims to do the same thing, provide a lot of drivers such that you can connect a lot of data sources. So, so Pig and Hive are more like a analytics tool on top of HDFS, so that you can churn a lot of data. Now, but that does not solve our need to have a database. Okay. Now, our standard databases do not provide us a huge data storage. Okay. Do not provide us huge data storage and do not provide us a high throughput. So Tuhin's question is, why do we need to learn Pig and Hive both? Only one is not enough. So uh, ideally one is enough. Okay. Ideally one is enough, and probably the Pig is enough in itself. Which one, Savita? So which one do you want me to share again? So basically, okay. So basically, in case of Pig and Hive, both are analytics tools. You do a lot of churning using these tools, but you needed a database, right? You needed a database. It's because uh, we have a file system, but that is not solving our purpose of storing data. Pig and Hive do not provide us a way to store data at a very high pace. Okay, it's not, let I mean we don't still have a great way to store the data at a very fast pace. Okay, saving the data into files is not something we want. Okay, it's just that most of our data is in a flat format. Therefore, we have mostly built our HDFS and everything to basically help us store everything. But still, we don't have a database. Therefore, people figured out that they need a database, and Google published a paper called Big Table. Okay, Google published a paper called Big Table, and before that, long back, Amazon has published a paper called Dynamo. Both of them were basically NoSQL databases. And after Amazon published a Dynamo paper, there has been lot of innovation in this domain, where we have to store mammoth amount of data, of big data, and we need to basically have a high throughput as in 10,000 TPS. TPS is the unit where we say transaction per second, and that is how we measure the throughput of any server or any system which is accessed by multiple people. So therefore this whole paradigm of NoSQL started. Now, on the funny note, So one person is asking, do you have any expertise in SQL? The other person is saying no. Then it doesn't matter. You can say I'm expert in NoSQL. Right. So yes, and Ajay's question is that HDFS actually invented for the same purpose. It is like saying that when you have file system, then why do you need a database? Okay. So file system was also stored for storing the data, but but in file system the data is stored in terms of blocks rather than records, and you are able to quickly access a particular record. In case of file system, in a file, physically if you have to delete a particular line or anything, you actually have to move all the bytes after that records up, right? You have to overwrite it. So therefore, record-based processing is very, very inefficient when we are dealing directly with the files. And therefore, Hive or Pig, both of them do not provide you a facility to write and read the records from the HDFS. Yeah. In database speak, you can say that for OLTP and OLAP transactions, you require database. All right. Just Savita, just hold your answer for a little bit and then we'll answer it. Okay. I mean, that's a little, you know, maybe after I finish NoSQL, I can answer those questions. So, what is a NoSQL database? In very, very simple words, a NoSQL database is a database which is run on multiple nodes in the network. It stores the same set of, I mean, for storing a set of data, it uses multiple nodes. Okay. And and because it has to identify which row went to which machine, every row is supposed to have a unique identifier, right? So in very, very, if you look at it very closely, NoSQL database is nothing but uh, a normal kind of a database which is run on multiple nodes simultaneously. Okay, and because it's running on multiple nodes, there are various kinds of behavioral changes which happen. Okay, and all those behavioral changes we will talk about, and we will also talk about what are the problems associated with NoSQL, what is the expectation you should keep in place. So first one is that there is an ID for each row. In any NoSQL, whether HBase, whether MongoDB, whether Couchbase, or whether DynamoDB or Big Table from Google, everywhere, every row is supposed to have an ID column, and that ID has to be unique. And it is very obvious then when some rows are being stored in one machine and some rows are being stored in another machine, to identify and figure out which data is where, you require an identification. Okay. So this is quite obvious that the ID has to be there. Second, unlike your SQL table, right? SQL table having an ID is optional. Now, second is these are next generation databases. They are there are multiple full forms of NoSQL databases. Some say it's non-relational, some say not only SQL, and but the thing you need to keep in mind, the only thing which differentiate NoSQL from other databases, is its property, a distributed property, meaning all NoSQL run on multiple nodes simultaneously. Okay, and everyone has got their own way of dealing with it. So this is a general speak. The common properties of NoSQL databases, most of them are open source. Most of them are horizontally scalable. How many of you know what is horizontally scalable? Okay, who doesn't know what is horizontally scalable? Okay, so horizontally scalable, I will show you this diagram. Okay, so you had a cart, you see the cart, and you needed to carry a lot of load. Okay, now now you had two bulls earlier, and when you keep on increasing, you keep on adding the bulls and buffaloes and whatever animals you got. Similarly, instead of discarding the old bulls and buying a bigger bull or hiring a elephant to pull your cart, instead you kept on adding whatever cattle you could afford, or whatever cattle was available in the market, right? Now the design of the cart is such that you can keep on adding these in the parallel. Okay, they all are helping to pull the cart. All right. Now that's the difference between horizontally scalable and vertically scalable. So in case of say Oracle database or say MySQL database, when you have to when you have to when the load increases on your server, when the database hits a lot of load, you keep on adding more hardware onto it, meaning bigger processor, bigger disk, bigger RAM, and so on. Okay, and you for some time you live happily with that kind of need, with that kind of requirement, right? You keep on adding these things. So that is vertical scaling, meaning you are increasing the hardware. Here you are not, you know, you are just adding more hardware in parallel. You are adding one more node instead of selling your old computer and buying a new one. Okay, you are using two computers to solve your problems. So this using two computers to solve your problem is horizontally scaling, and this horizontally scaling always requires a distributed processing because you got multiple nodes which will be doing your work in conjunction, right? So this is what a horizontal scaling means. The Okay, so anyway, these are all simple things, so I'll just move on. Now, why do you need a NoSQL? First of all, handle big data. Lot of data if you have to handle, you need to have uh, a database which can horizontally scale. And when horizontally scale means we should have an architecture which can support a dynamic addition of the nodes or dynamic removal of the nodes. Yes, all the things. It is basically related to both volume as well as speed. Okay. So when we scale up for both. First one is for handling large volume of data. Other is to handle large speed of the data. Scale out architecture, and basically it's the same thing. No, one is for volume, other is for availability. More and more concurrent users are coming and they're demanding a faster turnaround time, right? And therefore, you require a database for this kind of need. Like in case of Amazon, Amazon was probably the pioneer in the whole game. Before Amazon, there were systems like Memcache, where we used to keep a distributed storage of key value pairs for caching. Okay, caching is a way to keep everything in memory so that you don't have to look up the disk. Okay. So similar to Memcache, Amazon was using something called Dynamo. Basically, some people just made a hash table which is stored on multiple computers. So yes, so the data is replicated across various nodes, as well as same table will have chunks. of the data in different node. Both will be there. Okay, both will be there. All right. So now there are various kinds of NoSQL stores. First one is instead of calling NoSQL databases, I'm using NoSQL stores over here because some of these do not qualify for the definition of database. Okay. So NoSQL stores are basically categorized vaguely into four. First one is column oriented, okay, or wide column. Here, here, I mean, it is this column oriented one is the most close to what we have in our databases. Okay. Also, the column oriented ones are basically sometimes the column are the values of the same column are stored together, all right, and therefore they are also referred to as column. Under the column oriented category we have HBase, Cassandra and Accumulo, and all Cassandra is also pretty good database. HBase is also pretty good database. Similarly, we have got a database of type called document, okay, in which we basically form a big object in which you, just like we form an object while in any object oriented programming, an object can have sub object and sub object, and it can form a huge tree kind of structure. Okay, that is what is referred as a document. Like say we want to store TV shows. Each TV show has many seasons. Each season has many episode, and each episode will have many reviews and many cast members and then audio video stream. So if you have to store TV shows and you are storing it and you are using a document databases, you will be forming a big object and then storing it into the collection or into the database. Okay, so these are called document database, and MongoDB and Couchbase is most popular out of all. Then we have simple things like key value pairs. Key value pairs are mostly like plain text, both plain text, key as well as value. But now everybody has moved from plain text to having the value in the form of binary. Okay, now if you look at it, if the becomes an object, okay, value becomes an object, then there is not much of a difference between document oriented and key value. Just the difference is, so Savita's question is, when we say document, can that analyze the video audio feeds as well, just the way we can for text? So basically these databases will be used to store such kind of things. You slice your audio video into small parts and put it in a document, and then whenever you require you can just read that stream and start working on that. Okay, so Deepak, should I explain again or is do you need to connect again? Okay, so if you look at it, this also document also has a key, which is document ID, and then whole document. Similarly, key value is key and the value. Value can be binary and value can, it can store a binary object also. Then what is the difference between a document oriented and key value store? Basically, in the document oriented databases, you can look up on the on the sub object also. Say you want to find out in the TV, find out all the episodes which contain the name called XYZ. Okay, so you can make a query like where TV shows dot seasons dot episode like this. Okay, so indexing can be done on sub keys as opposed to the key value pairs. Okay, in the key value is just a atomic value where you cannot index on the individual value. So key under key value there are many databases: memcached, redis, rack. Most of these are the key value pairs, and I mean most of the key value pair, even dynamo was key value. And in redis and redis, basically redis and memcached are actually very similar to each other, in that both are like everything runs in the RAM. They are disk supported, as in if something happens to the data in the RAM, it is stored in the disk, but most of the processing happens in the RAM. Redis, HANA, and memcached, all these three are basically, every whole data is in the RAM when they are churning the data, and that is their value addition. HANA is SAP HANA. Okay, that also runs in the RAM. Now we have got something called graph, where where in the cases in the cases like these, say for Facebook, when we have to find out who is whose friend and how are you, which path connects me to, say for example, Jimmy. Okay, so finding out the common friends and then traversing to the basically, if you see the whole Facebook kind of systems, they are basically a map of all the people. A has connection to B has connection to C, and so on. So if you have a similar system and your need is about doing processing on top of maps, then you might require basically a graph kind of databases. Out of the graph database, the Neo4j is most popular. Right. So affinity tracking and connectedness, those kind of things require you to process a graph, and hence graph databases like Neo4j might be pretty useful to you. Okay. InfiniSpan is also, have you? No, I have not used InfiniSpan. I'll have a look at InfiniSpan. I'll take a note. So column oriented is actually very close to what you have right now. Okay. Basically, there are two kinds of column oriented and wide column databases also. I mean, don't worry. I'll actually, you will come to know about it anyway when we will cover HBase. Okay. When we'll cover HBase, you'll come to know about exact definition. Right now, I'll only say that it is the most close to the tabular databases. Okay. Can you also explain the mean stack and how it differs from lamp stack? Mean stack is what? Basically, I'm not sure I know about mean stack. Oh, okay. So basically, what they have done is MongoDB, Node.js, AngularJS. Okay, okay, okay. So I know about AngularJS. I've used it. I've used Node.js. I've used MongoDB. But it just happens that I don't know the name called mean. Okay. Yeah. So basically, the biggest differentiating factor is MongoDB. Probably I know about MongoDB very well. So in case of MongoDB, we have a lot of documents, and the biggest differentiating factor with respect to MongoDB is that it helps you handle large objects. Okay. So earlier what we used to do is, in case of relational databases, we uh, convert uh, convert each object into small relations, each relation is called a table. These Each employee has these name, these ID, and each employee has this salary, and the who reports to who. Those kind of we used to split it out. But in case of high throughput systems, we required that we don't need to form these objects again and again. So we started storing that object, and that's what MongoDB generally used for when you have a throughput requirement, high throughput requirement, and high availability and load balancing requirement. In case your data is going way beyond what can be handled by normal lamp stack, then you go for something like a MongoDB. Okay. Anyway, so that's altogether a different discussion. All right. So we have got NoSQL versus SQL summary. It's a standard one. Basically, right? So, so Jimmy's question is which one is better, NoSQL and SQL? So it all depends on what kind of data you are trying to store. And the way I look at it is they are not competing with each other. So all the transactional data where you have got strong financial data and that kind of data which have a strong requirement, then you will basically use SQL. And in other cases you will use, in case you have a need of a big data and there's a larger load, then you might end up using SQL. So no SQL. Okay. And here, so this table is basically a traditional table where we compare NoSQL with SQL. That I mean, standard RDBMS databases existed since 1970s, and in my honest opinion, none of the existing NoSQL databases have reached to that maturity, and basically none of these have reached to a maturity yet. Okay, so uh, the standard SQL databases, the way they solve the problem, none of the existing databases are yet have been able to solve the problems. Okay, so easily. Okay, now they started in 1970s based on CORD's paper, CODD CORD, and then NoSQL databases in started in 2000s, late 2000, basically 2004 probably. And examples of SQL databases are SQL, Postgres, Oracle, while NoSQL is MongoDB, Cassandra, HBase, etc. Data storage is relational, and in case of NoSQL it is actually not yet something like seamless. Everybody is having their own kind of model. Like we had map based, object based, and uh, basically the uh, the column oriented ones, key value pairs. So the focus of NoSQL databases is on the performance, not on the not on the basically manageability of the data. Okay. So when we think about NoSQL, the first thing that comes to my mind that should come to your mind is that whenever we have requirement of a huge data storage and a lot of huge data storage and a lot of load handling simultaneously, then you should go for a NoSQL. All right. Similarly, scaling is vertical in traditional databases. That is probably one of the big reasons. while scaling is horizontal in case of NoSQLs, right? Now, most of the since NoSQL databases, if they did not open source, they will not be able to get adopted because there is a lot of inertia to move from relational databases to NoSQL, and that is why they had to open source. So almost all the NoSQL databases went open source. And here the biggest difference comes in the ACID properties. How many of you know what is ACID property of databases? Or who, okay, let me ask this way. Who does not know what is ACID property of the database? Okay, okay, okay. So i- basically, let me then explain a bit. So almost all the SQL databases are supposed to have a property called ACID. Okay, this is as per the Cod's paper that almost all the SQL databases are supposed to have transactions which have A for atomic, C for consistent, I for D for durable, I for what was that? Isolated. Okay, so atomic, consistent, and isolated and durable. These are the four properties which every database is supposed to have. No, I don't think it's idempotent. It is. Okay, is that, I mean, what does I stands for? Doesn't it stand for isolation? Atomic, consistent, isolation, and durable. All right. So that is the those are the properties whereby whenever you add a data to SQL, okay, say there are uh, so atomic means either the whole data gets written and or nothing gets written. All right. Also, if you're trying to add the data in a single transaction to multiple tables, okay, so either all of these tables get updated or nothing gets updated. That is what we call atomic. Say you are inserting two rows into two different tables. If they are part of the same transaction, they either both of them get added or nothing should get added. That is atomic. All or nothing. Okay, that is atomic. And nobody should say, see the state in between. What does it mean? Nobody should, if we are committing, we are adding one row into table A, other row into table B, nobody should be able to see a state where a row was added into A, but not another row was added into B. Okay? Nobody should be able to see this transient state. They should either see the data without those rows in A and rows in B's, which we are trying to add, or after we have added. So nobody should be able to see half uh, job. Okay, that is atomic. And then consistent as in whatever we are adding to the database when we retrieve, it should be same as what we added. And then I for isolation. When two people trying to add the data, they should not see or they should not be able to interfere with each other's communication, right? And then durability is as in when we have added the data into the database, it should be persisted. It should not be that when we went if the light went off, it just disappeared. If I got a confirmation that your row has been added, we should get this row should be persisted as in saved to a media which is there in the which is you know which is available even after the computer shut down. Okay, so that is durability. So whatever you have you have saved, it should be saved. It should not be that it is got lost. All right. So that is durability. And yeah, so it's full back. Atomic is also called full rollback. Say you are adding some records into, say, 10 tables. In the ninth table, you got a problem. So all the other eight additions which have happened will roll back seamlessly without even anyone even knowing about that. Okay, and it will inform you back. So it will not make any change into the database. So those are the acid properties, and those are the properties probably everybody in NoSQL world is trying to get, but they are not able to achieve it, and there are very valid reasons to do that. Okay. Now, acid properties, as I was explaining, that acid properties are something which relational databases had, but NoSQLs have not been able to achieve that acid property. The common reason that has been given is in the form of cap theorem. Okay, why are we not able to achieve that level of consistency as achieved in the relational databases? So cap theorem says that out of consistency, availability, and partition tolerance, we can only achieve two at most. We cannot achieve all the three. And what does it mean by consistency in case of cap theorem? Consistency says that all the nodes see the same data at the same time. Okay, all the nodes in a network see the same data at the same time. No, so Savita, the isolation property basically is there, but consistency is something which is not greatly available in any of the systems. Okay, so you will understand it once we go through the cap theorem. Okay, so in the cap theorem, we say that either a consistency, availability, and partition tolerance, you can at most get two, not all three. Okay, what does it mean by availability? Availability is the guarantee that all the requests will be responded, will receive a response of failure or success, no matter what. That's the guarantee that which availability gives. And third one is the partition tolerance. So partition tolerance means even if one system is down, even if one system is down, the the system the your cluster will keep on performing very well. Okay, or you will still be able to access the data, or you do your normal operation even if one of the node goes down. Okay, so out of these three properties, none of the databases have been able to provide all the three, and you will understand why in the next diagram. And to have a look at which database provides what, you can look at this one. Okay, so some of the database provides you partition and availability. Okay, and some so these are quite common diagram which helps you figuring out which databases lie in which zone. Okay, now let's have a look at the this diagram. Okay, let's have a look at this diagram. Now say you have a single machine. All right, you have a single machine. There are two users trying to access it. Okay, now both these users are doing read write into the same database. Now in case this database goes down, then none of them will be able to access or read or write this data, which means your system is not partition tolerant. All right. Partition tolerance means in case any node goes down, your system still performs good. So your system is not partition tolerance. Second one is available. Now, say you got lots of requests, and some of the users are writing to the data, and while others are waiting. Okay, there are high chances that the if there are thousands of users waiting, the one of them will get a timeout. Okay, and therefore, as per my understanding, relational databases are not very highly available system. All right, but they are heavily consistent. So whatever user A wrote, if the user B tries to write instantaneously afterwards, he will get exactly the same data. Okay. Now that is a relational database. So relational database is able to achieve consistency, but not a great availability, and partition tolerance is really bad. While in the second case, which is your if you see the second diagram, this user is writing to the right this database, this database, and then the data is flowing to the first one, and this user is reading from this database. So all users are reading the database from the left hand side system, this one, and all the writers are writing to this second system. At any moment of time, readers and writers are not blocking each other, and hence such system is heavily available. Okay. Similarly, in case one of the node out of these two go down, the second one has good enough data to cater to your requirements. Okay. So hence it is basically a decently partition tolerant, while it is not consistent. If the user A wrote some data to the to the server, second server, and user B just after 1 microsecond trying to access, read the same data, they will not get the same data because the data is taking time to flow from one server to another. The replication, this replication is taking some time. So user writes here, and immediately if the another user tries to read it, it will be the data, it will not be there because it is not yet I mean, it has not yet moved from one server to another. It has not reached here, and therefore this is not considered as greatly consistent because the people are not reading what they wrote, right? So this system is not consistent. Now the third one, which is consistent as well as partition tolerant but is not available. Now look at this. So everybody is writing to one server, it has a replication in place, right? So both of them are trying to write to this node and they are trying to copy to the back one. And this is good in the sense that anytime this node goes down, the one from which everybody is reading, there is another replica of it available to take the place. All right. And therefore it is decently partition tolerant, while it is not really greatly available because one node is the bottleneck, and lot of clients will be waiting, and then there will be a timeout, right? So basically the whole idea of this diagram is to explain to you that it is almost impossible to have CAP all the three in all the three values. Okay, that's an impossible trinity, we call it, right? So most of the systems, most of the NoSQL databases are basically trying for the central one, which is which is eventually consistent. Eventually consistent as in, right now this user is reading an older data, but eventually the data will reach this server and they will be able to reach the correct data, and that is what we call eventually consistent. All right. Okay. RDBMS are also trying to be available partition tolerant there. So most of the RDBMS are actually trying for the second one, and this partitioning is happening based on the manual partitioning. But still, there are they are still in a very very starting stage. Okay, probably there is a you know further detailing required. Yes. So, to his question, let me answer. Yes, consistency is purely a business decision. Like when Amazon released Dynamo, it upfront said that we don't want consistency and therefore we are going for such system. Okay, because cart, in case of handling the cart, we required a huge hugely, extremely fast database. Okay, just a second. Let me go through. Yeah. So consistency is purely a business decision. Yes. Then Gunjan's question: isn't HDFS with secondary name node and multi-node structure then conforms with CAP theorems? Just that. So basically, if you look at HDFS also, basically HDFS is not greatly available because is name node is your bottleneck, right? Name node is your bottleneck. So there it has little bit on the lines of, I mean, it's not greatly available, but it is decently available. No, there are not so many questions. So HDFS has taken consistency over availability. So HDFS is, you can say that, is not greatly available but consistent and partition tolerant. Now let me have a look. Mm, okay. But does that mean that RDMS will have to compromise on coordinate part to get available? Yes. So in case people try to modify RDMS to cater to the high availability. Okay, high availability as in they started the way in 2005 and 2004 2003. In those days when people wanted to cater to larger user base, they had to partition their databases such that the data from one geography is stored in one database, other geography stored in another database, and so on. Okay, so to become available, they had to split out the data in this format. And when this was happening, you'll have an I mean, you will have a lot of duplicacy of the same data so that the data where it is being written does not get impacted. Instead, we keep on using another data. Right? I'll explain to you. You will get a hang of it. Eh, So, Ajay, that is true with every case of data. Almost all the databases are designed with the thought in mind that the ratio between reads and writes is going to be 10 is to 1, meaning 10 there are going to be 10 readers and one writer on an average. Okay, so that is true for even the relational database also, and that is why we have indexes. Okay. So Arun's point is that in Oracle RAC, you can have 8 to 16 node working, but like in second picture, they don't do replication, but use shared storage and global locking to access the data. Right. So that's interesting. That's interesting. So almost everybody is trying to reach the same. Maybe I'll have a review of Oracle RAC. Okay. So whenever basically consistent and available go just opposite to each other, and therefore most of the systems let go of consistency in favor of availability. So consistency, yes, you are required in case of transactions. Not really, not really. Okay, because see the theoretically like here, it's actually when you look at the data closely, it and okay. So this is what the cap theorem says, and most of the, I mean, cap theorem is a universal theorem which actually explains why it is not possible to have all the three at the same time. Okay, but lot of people are trying to make it, such that the availability is high and it is consistent enough, not perfectly consistent, just like your RDMS. These databases are like consistent enough or eventually consistent. So let's take a look at what happens when you are launching your website. Say you are launching your website today. It's an initial public launch. You move from local workstation to share. So today is your launch of your website. This is the standard story, and I have also gone through it a couple of times. Okay. In OLTP and OLAP, both are mandatory. Yes. So whenever we talk about online transaction processing and online OLAP, what do you call it? Um, I forgot. I keep on forgetting OLAP's full form. So both, as in you can have consistency, but availability is never guaranteed in case of in case of your RDMS. Even if availability is guaranteed, then there will be no partition tolerance. There will be a single machine doing everything. Okay, and effectively availability will be hit very badly. I'm trying to answer Iraya's question. Now I want to go take you through the standard way when say you launch a website, say like a Flipkart, for example. What's the story that goes on? So planned that okay, your initial launch is today, so moved from the dev machine. You basically you started working on a lamp stack, and everything is well defined schema, and then after everything is past your QA and you are able to do a decent amount of job, and you are able to get a decent enough throughput, you launch it and you move it to the production servers and then launch it. Cut the ribbon. Service becomes popular and there are too many reads hitting the database. Okay. And so what you do is to handle the common kind of queries. I mean, we're going step by step. You did some PR, service became popular, too many reads hitting the database. What you did was you put a memcache kind of a caching system which centrally keeps a cache of all the things. So instead of again and again preparing objects, order detail, object details, and all sorts of things, it keeps a cache of all. Now, the moment you put memcache into place, which means that I mean, your data is basically cooked and prepared all the time. Every time you change any of the data, you will have to refresh memcache, which means that you anyway have let go of your acid property. Okay, because cache data will expire and then only the new database data will be read. If you keep on expiring every minute or every second, then there is no point of having a cache. And therefore, memcache, placing a memcache, which is a caching solution. Caching solutions are what? It's like a central hash table or central memory onto which you put your objects or put your data, such that you don't have to make a trip to database and query multiple tables to get a particular object. Okay, so all the data which is more frequently accessed is going to be in the cache. And anyway, when you put a cache, you anyway have let go of the strict acid properties, because the data in a cache is not always in greatly sync with your database. Yeah. So memcache is to be read heavy, yes. So whenever you have a heavy read requirement, not the writes are very, very sparse, then you can cache it. Like in case of Flipkart or Amazon, the detail about each object changes very, very rarely whenever you there are products. So the specification of the product does not change too frequently other than the price. So most of it can be very well cached. Now, price except for price quantity, you can actually cache almost the whole object. Right? And then as soon as the objects are changing, you have to expire the cache, and therefore there will be a delay between the actual object's value and what is in the cache. And therefore, it is not greatly a you no longer have a great acid system. All right. Now, next step is that you are happy actually that your memcache, the moment you place memcache, you will get a great relief for few more days, and the service key will continue to grow in popularity. Everyone will be using it once in a day, and that's when there are too many writes hitting the database. Okay, now when too many writes hitting the database, that means that uh, you know you'll have to increase your database. When lots of people are writing reviews, lots of people are you know mm, uh, placing order, lots of people are uh, doing all sorts of transactions on your website, then there will be too many writes, and your MySQL will have to put all sorts of hardware into it, have 128 GB RAM and 16 cores, and have a very costly hardware. Now now you'll be happy for again for few more months, and after that as as your product is maturing, you'll have more and more features. More like, you only had price earlier, now you have something called bid, and then you have discount, and then all sorts of features are there. Okay, group discount is there, all sorts of features. As the features keeps on building, the query complexity will keep on going. The query that prepares the object details will keep on having too many joins. Now, what you will do is, instead of keeping discount, coupons, and product details pricing in separate table, you will try to combine them to avoid lot of joins, because every feature is keeping its data in a separate table. And since there are too many writes, it becomes very difficult to handle too many writes, right? So therefore, you start denormalizing your joins. You start merging this data, even if they don't belong together right away mathematically. You try to join that and keep it in a simple and at a single place. So that is what is known as denormalization. Denormalization is merging, basically opposite of the normalization. In normalization, we used to convert the whole data into tuples and define the standard RDMS way. And when you let go of your, if you see, first you let go of your acid properties, now you are letting go of your normalization. And that's when you realize that database is not database what we used to think of it. The main role of database was the way we have thought about relational databases, the way we have been taught in school, that you have to normalize your data as well as you have to keep the acid properties intact. Both have gone haywire. And that is the real story. Okay, that is the real story. Now, further your popularity, the more marketing you are doing, people are talking to each other, telling everybody that, hey, this system is great. You move on to new geographies, and this rising popularity further makes things slow. Okay, now the next thing you start doing is you delegate lot of server side computation or database side computation to the client side. The way, like, computing, the way we had done it is that converting, displaying the time, and formatting various values, we left it to the clients. Okay, so that the main servers are not hit badly. Okay, now after this, like triggers and everything, you will stop immediately. You will stop triggers, you will do other kind of computations, you will stop immediately. Then, and some queries still will become keep on slowing. So what you will do is, for common queries, you will keep objects ready so that you don't have to query at all. Okay, and stop joining in most of the cases. Now, if you see the whole scenario, you will end up, your standard RDMS will not be able to handle without creating a having a distributed kind of architecture any of the requirements. Okay, and this is the true story. Okay, now the more writes are more read, to make reads faster, you create indexes, and that slows down your writes. And when you tries to speed up your writes, your reads go slower, and that's the standard case. Okay, and that's where you realize that you might need to move to another kind of database. And that's the story. This whole story is about Amazon. The reason why they came up with Dynamo, it was because we needed a solution for our website. Okay, before Christmas. Okay, so because Christmas time, forget about your systems, it becomes really horrible. Okay, because there are so much of demand that you can't even imagine, and therefore none of the database was actually solving our purpose. And for that matter, even though we have no SQL and other great solutions at Amazon today, we still use Oracle for lot of transaction based systems. Okay, we still use Oracle in a very great usage. Probably Amazon is one of the biggest user of Oracle. Okay, so in case of transactional systems where the money is involved, okay, the moment you place the order, that part after that, the after placing the order, the whole workflow is via Oracle. Okay, why? Because we require a greater consistency, and we do not want any sort of problem with availability. So those portions, the after the order is placed, those portions can be very well handled using Oracle, because total number of actual order placing is very small as compared to total number of the request hitting our servers. All right, does it make sense to you guys? So this is the standard RDBMS story, and that's when the HBase kind of database come into picture. And the other thing which I want to describe you, Ajay's question is still hanging, that what is a column oriented database? Okay, so column oriented database is something of this sort. Now you look at the table. At the table level, it looks very great. Row-oriented database under the hood will be converting it into such a format. So each row, say this one is named at 001, 002, 003. So it will be storing 001, 10, and 10 Joe. 10 is like 10 comma Joe. And then under the row ID called 002, we have 12 comma Mary, and then 11 comma Kathy. So columns are basically stored in this way, and it is guaranteed that this row and the next row is going to be continuous. Okay, these are going this and this are going to be continuous, and so is this one. All right, so these are row oriented database. So here rows are supposed to be stored together. Okay, and in case of column oriented databases, the values in columns is supposed to be stored together. Okay, so this is how it is. So we say 10. So first we store all the columns 10, 12, 11. Okay, then we store the second column Joe, Mary, Kathy. Right, so these are called column oriented databases. So instead of storing things row wise, we are storing things column wise internally. At the surface, it looks same, but under the hood, we are storing it column wise. All right. Yeah. 001 and 002 are the distinct keys, the row identifiers. In column, the different columns may not be related. Right. Un- right. So but HBase is not really a column oriented. It is more like column family oriented. All the values of a column family will stay together. Okay, we'll talk about this. So in summary, these are the properties, the huge property list I have done. So let me have a look what you're trying to say. 10 is no, the relation remains same, Savita. So from the relation perspective, both are saying the same thing. But when they're storing in the file system, because every database at the end of day has to store it on a persistent mode, either file system or SSD or somewhere, right? So when storing, the way column oriented stores is it stores first one column, then second column, then third column, and so on. Okay, relation wise they stay the same. So when storing into the actual, the disk, then instead of storing row wise, first stored the row, then first row was stored, then first second row was stored. It will store column wise. Well, it will store first column, all the values of a first column, then second column, and then third column. The way we have shown here. So in column oriented database, basic storage block is small. Let me just reread it. Mm, no, I think it will be. I mean, it wouldn't make much of a difference in that way. It wouldn't make much of a difference that way because the basic storage block, they are going to anyway utilize the standard file systems blocks, and on top of it, they will be creating their own blocks. So I don't think there is a correlation between the two. Okay, the only reason is that the column oriented might, you know actually be bigger than the normal block. So in the file system it will be the same thing. Okay, but the way it is stored, I mean, it is their call, because rows are anyway sliced. Okay, rows are anyway sliced. If you see, the HDFS will not let you store more than 64 MB, right? And therefore, okay, therefore you are only left with columns, right? Rows are anyway sliced, so therefore it makes a lot of sense to store all the columns together, because when people try to access the columns, it will be faster than actually row wise. And the way HBase or any such system performs, they do this on column family based. Okay, and such that whenever we are needing a column, we need all the values of this column, not only some. Okay, because in any way we have to compare and iterate. Yeah, so yeah, because we will be querying more per column in a small cluster, a small chunk, than per row. Per row, that the differentiation whenever you execute the query per row will be distributed across the network anyway, right? And whole chunk will be iterated. You will get the hang of it, maybe once we discuss about a bit more about HBase. So HBase is CP, which is consistent and partition tolerant, as opposed to the MongoDB, which is more available. Here it favors the consistency and partition. Okay, it, and compromises a bit on the availability. Okay, and it is column family oriented database. It is column family oriented database. This is based on a paper published by Jeff Dean and Sanjay Kemawat, called Google's Big Table. Okay, and rows are stored on different machines. Okay, because row each, and hence each row has got an identifier. So one subset of row will go on to the one machine, other subset will go to another machine, and that is stored in HDFS. Okay, so each of these chunks are going to get stored in HDFS in that similar the way we had described earlier, and columns are further grouped into column families. Okay, so uh, each table has got columns, and columns are further categorized into column family 1, column family 2, and so on. Okay, Sure. So we'll talk about the further storage of HBase again. Okay. First, we'll just go over the basics of HBase. So columns are grouped by column families. Column families are stored together. The way we had described the whole columns are stored together. Similarly, column families are going to get stored together. And the most important part you should note down is it is good for hundreds of millions or billions of rows. Okay, it's not good for tens of millions. If you have if you have got 1 crore rows at max, then you don't require HBase. If you have got 100 millions, which is 10 crores or 100 crores rows, only then it makes sense to have HBase. And also uh, a lot of columns. If you have got thousands of columns by hundreds of rows, 100 million rows, then you make sense. It makes sense. If you got smaller than that, then it does not make much sense. Okay. So it is favoring consistency in which it is not eventually consistent, it is immediately consistent. And these are automatic sharding. Sharding is division of the rows. Okay. And automatic failover at as well as automatic sharding, it is not eventually consistent, it is immediately consistent. Okay. And it runs on top of HDFS, and the most of the churning is done via MapReduce. It does not provide you a way to do select star from this table, that table, but it provides you where, I mean, the database per se does not provide any of those features. The drivers which have been written on top of HBase, they provide you a complete SQL. And under the hood, any query will result in MapReduce. Okay. And the API of accessing HBase is very, very simple. And it is first written in Thrift, and hence it is available for almost all languages. So you can use HBase with any kind of programming language. And there are smaller features like coprocessors and Bloom filters. We will talk about these later. Okay. So I think we should continue our HBase in the next session tomorrow. Yeah, thank you. Yeah, Arun. Let's talk about it tomorrow. And yeah, I like to go slow, even if we even if we are a little bit late, right? So then see you tomorrow and try that Hive assignment for sure. Okay, try that Hive assignment for sure. And all those who have not finished their assignment, please finish the assignment so that because the class is only 3 more classes are left probably. Yeah, thank you all. Have a great time, and make sure that you write a review of us on Facebook, and maybe follow us on Facebook or Twitter. Okay. I'll consider that as the gift on the Teachers' Day. Thank you very much. It's a great class. Right. Yes, Arun. Yeah, I'm asking for the gift. You see. Bye bye. Have a great time. Okay. Okay, Prashant saying that we should, yeah, I think we should not overflow the class beyond 10, 15 minutes. Okay, I mean, let's not overflow the class. We'll just keep it 3 hours. Okay. And so, because Prashant, the way I had, structured the course was actually for the 3 hour session. That is why I'm sticking to it. Okay. Thank you guys. Have a great time. And feel free to let me know in case you get stuck somewhere. All right. Bye bye, Tuhin.